Equivalent Fractions, a Biscochitos cookie recipe by Mrs. Orta, 3rd grade math. Biscochitos are traditional Mexican sugar cookies that my family enjoys baking and eating during the holidays. Have you ever helped someone bake or cook by following a recipe? Let's look at our objective for today. Explain that two fractions are equivalent if and only if they are both represented by the same point on a number line or represent the same portion of a same size whole for an area model. This targets our 3rd grade objective 3.3G. How will we accomplish this objective? We will do this by multiplying fractions by the fractional equal value of 1 in order to generate equivalent fractions within a real-world application. First, let's review what we already know about fractions. How can you explain a fraction? A fraction is the value given to a portion, piece, or part of a whole. So, let's look at the example of the area model here. Notice the model is divided into 4 equal parts. 3 parts are blue and 1 part is red. Each piece represents a fraction of the whole area model. This means that when we combine the 4 separate pieces together, we get the whole. What fraction names the red portion or piece of the area model? The fraction that names the red portion of the whole area model is 1/4, written 1/4. So, in the fractional value of 1/4, the 1 on top is the numerator, or how many parts from the whole we are identifying or talking about. There is only 1 red piece. The line is the fraction bar, or the division that separates the 2 different amounts. It can also be viewed as a division sign or symbol, so 1 divided by 4. The 4 on the bottom is the denominator, or the total equal parts the whole is divided into. There are 4 total parts, 3 blue and 1 red. So let's take a closer look at equivalent fractions. What are equivalent fractions? You remember, equivalent means the same as when comparing the value of 2 or more different amounts. So that means that equivalent fractions are parts of an equal size whole that have the same value even though they don't look like each other. For example, 1/2 has the same value or is equivalent to 5/10. It is also the same as 10/20. Let's look at the Biscochitos cookie recipe. These Biscochitos follow a secret family recipe, so I'm only going to share a few ingredients that involve fractions. We have 1/2 cup brown sugar, 3/4 cup flour, 2/3 cup butter, 1/4 cup cinnamon, and 1/3 cup water. It's amazing how many fractions are involved with recipes. Let's create an equivalent fraction for one of these ingredients. Remember when we covered our division unit? We learned that any number other than 0, when divided by itself, is equal to 1. Sound familiar? For example, 2/2 or 2 divided by 2 is equal to 1. In other words, 2/2 has a fractional value equal to 1. So, since we know that division is the inverse operation of multiplication, one way to generate equivalent fractions is with the use of multiplication. For example, we can multiply the unit fraction 1/2 by 1 and not change the value of the 1/2. Let's practice generating equivalent fractions using multiplication. We can take the unit fraction 1/2 cup brown sugar from my Biscochitos recipe and find 2 or more equivalent fractions for it. Ready? First, we know that 2/2 has a fractional value equal to 1, which means the whole cup is partitioned into 2 equal parts. In this case, the amount of brown sugar we need for the Biscochitos is only 1 part of the 2 total parts. In other words, 1/2 cup. So, if I multiply the unit fraction of 1/2 cup brown sugar straight across by 2/2, my numerator 1 is multiplied by 2, and my denominator 2 is also multiplied by 2. This makes an equivalent fraction with a new numerator of 2 and a new denominator of 4. We read this resulting equivalent fraction as 2/4 cup brown sugar. If you think about it, 1/2 cup brown sugar has the same amount of brown sugar as 2/4 cup. The denominator 4 comes from the idea that if we take the same cup that we first divided into 2 equal parts, and instead we divide it into 4 equal parts, 2 parts of the 4 total parts have the same amount of brown sugar as 1 part of the cup that was divided into 2 equal parts. Let's try generating equivalent fractions once again. We know that 3/3 is equal to 1, so we can multiply 1/2 by 3/3. Now, our new numerator is 3, and our new denominator is 6. We can then say that our second resulting equivalent fraction is 3/6 cup brown sugar. This means that if we partition the same whole cup into 6 equal parts, instead of just 2 equal parts, when we fill the cup to 3 of those parts, we end up with the same amount as 1/2 cup brown sugar. Finally, let's take 1/2 and multiply it by 4/4. That is to say, 1 whole cup has been divided into 4 equal parts. Our numerator 1 times 4 yields a product of 4, so our new numerator is 4. Next, our denominator 2 times 4 yields a product of 8, so our new denominator is 8. This means that we end up with 4/8 cup brown sugar, which is equivalent to 1/2 cup brown sugar. Now we know how we can use multiplication to generate equivalent fractions. Let's review. 1/2 is equivalent to 2/4 is equivalent to 3/6 is equivalent to 4/8. They all look different, but are equivalent because they all have the same fractional value. Do you notice any patterns or relationships between the numerators and denominators? If you take a closer look, you'll notice that the numerator in each fraction is half the value of the denominator. If we take 4 and divide it by 2, our quotient is equal to 2. If we take 6 and divide it by 2, our quotient is 3. If we take 8 and divide it by 2, our quotient is 4. This means that any whole number divided by 2 is equal to 1/2 the value of that number. You get the hang of it now, don't you? Next, you'll answer the following questions in your math notebooks. Think and discuss. Think about how knowing about equivalent fractions can help us when following recipes. How can our understanding of equivalent fractions help us when cooking, baking, sharing foods, or other activities that involve measurement? Turn to discuss answers with your partner. When you each have shared your answers with each other, stand next to your desk to signal that you're ready to share with the class. Math Journal Entry 1. Explain how we can use multiplication to generate equivalent fractions for fractional parts of the same size whole. You may write your explanation, illustrate it, or justify it with an example using area models, number lines, fraction bars, fraction circles, or measuring cups like we did here in this lesson. Math Journal Entry 2. How is a measuring cup used to represent fractions?